Here's how we solve this. Steps used to get to this solution. When we started this off, we knew we had to get everything out of this exponential function. In order to do the opposite of the exponential, e, we do a log with the same base e, which is the natural log. We need to take the natural log of everything on the left side. So we took the natural log of the entire left side. If we take the natural log of the left side, we also have to take the natural log of the right side as well. So we took the natural log of each one of the original sides. On the left side, the inverse property of functions tells us because the natural log and the function e are inverses, they counterbalance each other. So the natural log and the e function negate each other, cancel each other out, and we get everything that was in its power on the left side instead, 2 minus 3x. On the right side, this is a trick of properties with logarithms. We were told that if we had a logarithm with something in top divided by the bottom on the inside, we can break it apart and we get the log of the top thing minus the log of whatever was on the bottom. So in this case it was a natural log, so we kept the natural log. And if you type natural log of 1 into the calculator, or remember the graph of the natural log, its height is a height of 0 when you plug 1 in. So you can either put it into the calculator and just type it, or graph it and see its height is 0 when x is 1. So we're left with this negative natural log of 2. At this point, we want to get the 2 over to the other side. So we could subtract 2 here, subtract 2 there. Anytime you've got things separated by a plus or minus, they're allowed to hop on the other side at the cost of changing their sign. So if this is positive here, it'll appear on the right as a negative. If this had been negative originally, we could have jumped it over here and put it as a positive. That only works if it's either being added or subtracted. If it's multiplied or divided, it won't work that way. Just adding and subtracting, you can put it over and change the sign. So we subtracted the 2 and got it over. Then we were left with negative 3x greater than all of this stuff. This is the step that's most crucial when it comes to inequalities. Here we divided by negative 3. Division or multiplication by a negative number causes the inequality symbol to flip and turn around. Only if it's a negative number and it's either multiplication or division. Anything else in it won't cause it to flip. So here it was division and it was a negative. We did it on both sides. That causes our inequality symbol to flip around. And now on the right side, what we want to do is just kind of tidy up. So we factored these negative signs out and said, well, we could take the negative out of each one of them and pull it on the outside. If you're not sure, you could always go back and try letting the negative get distributed and multiply back in. It would hit the natural log, making it negative, and then it would come back and hit the 2, which would make it back a negative 2. So you can always double check it by asking, what happens if we let it go back in? Do we get the original thing and the step above it back? So here it looks good. We pulled it out correctly. The negative here is like a negative 1, and the negative will cancel with that in the bottom. And then at the end of the day, we get this nice tidy result. If you wanted to change this and write this in interval notation, you could. So you might just say something like, or. Interval notation tells us its x value is less than this number. So anything less down to negative infinity, but not including it works, or up to this number, natural log of 2 plus 2 over 3 works as well. Not included, there's not an equal to part. We can't be that number. We are strictly less, no more or equal to, we can't be equal to it. So this is the final answer. What we'll do is we'll look at a graph and see what this looks like. This number, if you throw it into your calculator, turns out to be something like 0.898, 0.898. So what we're thinking is when we look at this on the graph, there's something special about the number approximately 0.898 that we want to see. Looking at a graph to help us understand the result, we're going to graph the left side of the inequality, which is right here, e to the 2 minus 3x. That's our green line. On the right side was a half. Since it's a height, physically, we'll write y equals a half, and we get this purple line at height half. And now we ask the question, where is basically the green line above the purple line? And it's pretty obvious, right here, it's all above this purple line. But our answer doesn't talk about the heights. The answer is going to talk about the x values for which that happens. So we'll click right here, and we notice there's the cutoff, 0.898. And we've already taken the liberty of typing in our solution to see that 0.898 is exactly what we got for our solution. So the question really is, how do we write this out in interval notation? And if we notice, this is once again an x value. So if x equals that value in particular, we get this vertical line right here. Here's the x on the x-axis. The question is, should we go to the right or the left? And the obvious answer is, our green line is higher than the purple when we go to the left, which is less than. So the solution is all of the x's that are to the left of this. And you can type it into Desmos. You could say this is less than or equal to, and it shades it in, telling you our green line is higher than the purple in that region. So our solution was all these values out towards negative infinity up until we get right here at the value 0.898, which we said is exactly natural log of 2 plus 2 over 3. So these are the key components in solving these inequalities, what to look for graphically, and if you have any questions or have problems that you'd like to see worked here on the Math Informant, feel free to send them. Hope you found the solution helpful and look forward to solving more problems for you in the future. Take care. Bye-bye.